For this lesson, what we're going to do is we're going to talk about angle measures, and we're going to use a new measurement. We oftentimes measure angles in degrees. Now we're going to talk about a new way of measuring angles in radians. Because radians are used more frequently in trigonometry, we're going to make that transition. But first, let's go ahead and talk about something that we already know. Let's talk about temperature. We oftentimes measure temperature in different ways. We've got things like degrees, and we also have Celsius. Now, degrees is how we usually measure our temperature of the weather, for instance. But in science and other applications, we oftentimes measure it in Celsius. Celsius is where the temperature is measured where 0 is freezing and 100 is where we have a boiling point. Now, the formula for converting from degrees to Celsius is 5/9 times the temperature in degrees minus 32. So if we try to convert 72 degrees into Celsius, 72 minus 32 is 40. 40 times 5/9 is going to give us 200 over 9. And then when we reduce that to or use a calculator to find a decimal for that, we go ahead and estimate that at about 22.2 degrees. And that's in Celsius. Now, what we want to do is start measuring angles in what are called radians. First, what I'd like to do is just show you how there's similar types of conversions for this. If we have an angle in degrees, and these degrees don't apply to these degrees, they're not related, they're just the same word, but in this case, an angle of 30 degrees in our geometry system, we're very familiar with like 30, 60, 90 degree triangles. If we want to convert that 30 degree angle into radians, the formula is taking the angle in degrees and multiplying it by pi over 180. If we take 30 times pi over 180, what we get is 30 pi over 180. When we reduce that down, we go ahead and reduce it, we get pi over 6. And that's the exact value of that angle, 30 degrees in radians. Now, we could convert that into a decimal using a calculator, but it's very typical that we leave the radian measure in trigonometry in the exact form of pi over 6. So now what we want to do is go ahead and talk about how we find radians, what that system of measure is based upon. So when we look at radian measure is where we take on a circle where we have a central angle here, like we did in geometry, a central angle. If we look at the arc length of this, so this is our arc length here. If we take that length and we divide it by the radius, we get the measure of the angle in radians. That's why the root of it is the same root as radius. It relates to the circle. So let's try a specific example of this. Let's say that in this circle, this radius is 5 inches. And up here, this arc length is measured to be 2 inches. Well, the radian measure of this angle right here, I'll call this theta. Theta is just going to equal the 2 inches over 5 inches. Now notice one of the advantages of radian measure is that we now have the unit of measure reduces out in the fraction, and 2 over 5 becomes a decimal of 0.4. Notice that this angle measure doesn't need a degree marking, doesn't need any unit marking. This angle measure is free of units. That's one of the advantages of radian measure and why it's so helpful in the use in trigonometry. So what we want to do now is do some conversions of different values into radian measure. Now we're going to take this information and we're going to use our conversions. First of all, just a reminder, radian measure here, this is the idea that it's based on, is it's the arc length over the radius. So if we look at these, we want to talk about using it in terms of circles with that central angle. Now to convert from degrees to radians, what you do is you take the degrees and you multiply by pi over 180. Now if you want to instead convert from radians, if you start in radians and want to convert to degrees, you take the radian measure, whatever that radian measure is, and you multiply by the reciprocal of that, 180 over pi. So very simple conversions, you just got to keep straight which one you're using to convert. So these conversions are the ones we're going to use in doing these problems. All right, let's try a couple problems here. We're gonna do a couple and then I'll fill in this chart. We want to have this chart filled out because these are the standard angles that we typically use in trigonometry when we're working with what's called the unit circle, which we'll come to in a future lesson. So first of all, it makes sense that if we take 0 degrees and we multiply it by pi over 180, we're going to get 0. Okay? Now, I'm going to do 45 degrees here. Okay? We already did 30. Remember the 30 we got pi over 6 previously. Let's do 45. So 45 degrees times, and we're going to take this and we're going to multiply it by pi over 180 degrees. Notice that the degrees now cancel out, so we have no units. We're going to get here 45 pi over 180. And if we reduce this fraction, the 45 and the 180 reduce down, and that gives me just a pi over 4. So I get pi over 4 for this measure here. If we were to do, let's go ahead and do 360. 360 is a full circle around, in the full circumference around the whole circle. So 360 degrees times pi over 180. If we multiply that, we get 360 times pi all over 180. The 360 and the 180 reduce, and I'm left with just a 2 pi. Now, I want to show you how that makes sense in a different way. Notice that if we talk about arc length over radius, arc length, remember if we take a full circle, the circumference of a circle is 2 pi r over the radius, which would just be r. The radiuses reduce out. That gives me one full circle angle measure as 2 pi. Notice that that conversion helps me find that. So just filling in the rest of this chart, and these are ones you want to use and get very familiar with. 60 degrees is pi over 3 when we convert it. 90 degrees is pi over 2. 180 degrees is just pi. 270 is 3 pi over 2. And 2 pi is 360 degrees. So we want to become very familiar with that chart. Now let's try a couple sample problems to see how you do with using these conversions. Let's try these two examples. Pause the video, try to convert 50 degrees to radians using this conversion, and then convert pi over 9 to degrees using this one, and then we'll come back and do it together. Now that you tried that, let's do 50 degrees first. So to convert this to radians, we take 50 degrees and we multiply it by pi over 180. Think of 50 over 1. That becomes 50 pi over 180. We can reduce that down now, and as we reduce it, we take out a 10 out of both, and we get 5 pi over 18, which is as low as it goes, and we're going to leave it in that exact form. Now let's convert this pi over 9 to degrees. So take pi over 9, And since we're converting it to degrees, you go up here, convert radians to degrees. We'll multiply it by 180 over pi. Notice that when we do that, the pi's reduce out, so we get 180 over 9. That reduces down to 20 degrees. Okay, and this was a degree problem, so that the degrees are added into the problem. So, what we've talked about is being able to use radian measures for angles. Radians relates to circles, and the root of it has to do with radius. And if you take arc length around a circle to the point where the angle ends and put that over the radius of the circle, you get the measure of that angle that's been formed. And we have two conversion formulas to use. To convert from degrees to radians, we multiply the degrees times pi over 180. If we convert from radians to degrees the other way, we multiply the radians times 180 over pi, and now we can use radian measure in our trigonometry.